So let us try to understand how to draw the acceleration diagram in case of the simple mechanism like single slider crank mechanism. So here the single slider crank mechanism is in action. So this animation shows the single slider crank mechanism. So here we are having this crank which is rotating and the slider B is reciprocating inside the cylinder, and from this end up to this end it is the stroke length of that particular piston. Now this OA is the crank which is rotating uniformly in anti-clockwise direction as we have seen in the earlier animation. AB is the connecting rod and it is oscillating, and the oscillation is non-uniform, and B is the piston which is sliding inside the cylinder in reciprocating fashion, so it will have linear acceleration. Now as this particular crank is rotating uniformly, it will have only radial acceleration or centripetal acceleration. So there are two types of the acceleration. One is radial or centripetal acceleration and another one is tangential acceleration. Now as the crank rotates uniformly, the tangential acceleration will be zero. So this crank will have only radial acceleration. And we know that radial or centripetal acceleration is always directed towards the center. So O is the center. So here the radial acceleration of A with respect to O will be directed towards the center. Now suppose we assume, now here in this particular case neither A is fixed nor B is fixed. So radial acceleration of, we can say, either B with respect to A or A with respect to B. If we consider this A as the center, then radial acceleration of this connecting rod will be directed towards the center, that is A. So this is the radial acceleration FRBA which is directed towards A. Tangential acceleration is always perpendicular to the link. So here this is FTBA which is perpendicular to this link which we have shown over here. There is nothing but the connecting rod. And linear acceleration of the piston is along the path of sliding. It is parallel to the path of sliding and it is sliding with respect to the fixed point, that is O. So these are the various vectors, acceleration vectors that we have shown over here. Out of this particular radial acceleration of crank, that is A with respect to O, and radial acceleration of B with respect to A, those are known in magnitude as well as in direction, because the magnitude of this particular can be calculated by using velocity diagram. So both these vectors, they are, that is FRAO and FRBA, they are known to us from the velocity diagram. So radial acceleration is given by square of the velocity vector divided by the link length. Now as this connecting rod, it is oscillating non-uniformly, it will have both radial acceleration as well as tangential acceleration. And as this slider, it is sliding and it will have only linear acceleration, that is FB with respect to O. Now let us consider this fixed point O in the space over here. So this is the point O. From O, now we'll consider our first vector. This is nothing but radial or centripetal acceleration. Now this radial or centripetal acceleration is directed towards the center, so we have to follow this particular direction. So here center is nothing but O, A with respect to O. So this is the direction. So we'll draw a vector parallel to this vector from O with some suitable scale to some certain centimeter length. Then the second vector is FRBA, that is radial or centripetal acceleration of B with respect to A. So out of this B and A point is known. So from A point, draw a line parallel to this vector to a certain scale. So this is nothing but FRBA. Now this tangential vector of B with respect to A, whose magnitude and direction we don't know. So we'll draw it from this X point. Then B with respect to O, fixed point. So O point is known. So from O point, draw a line parallel to this particular line. Wherever these two lines, they intersect each other, that is our point B. So this is nothing but tangential acceleration of B with respect to A. Now this is the resultant acceleration. So this connecting rod will have radial acceleration as we have already shown over here. Then it will have tangential acceleration, that also we have shown over here. And it will have this resultant acceleration. This is the acceleration of piston B with respect to O. Now, as we are finding out the acceleration of B with respect to O, the arrow must be towards B. Here also, as we are finding out the acceleration of B with respect to A, arrow must be towards B. And this is the resultant acceleration of connecting rod. So it is B with respect to A. So we are finding out the resultant acceleration of B with respect to A. So arrow must be towards B. So in this way, we can draw the acceleration diagram in case of the single slider crank mechanism.